Okay, let's continue with implicit differentiation. But before that, do you know what is implicit function? Implicit function, not implicit differentiation yet. Okay, sometimes function are given not in the form of y equal to mx, y equal to fx, but in more complicated form in which it is difficult or impossible to express y explicitly in terms of x. Such functions are called implicit function. Okay, what if the function has more than one variables? Okay, again, we discuss about variable which is more than one variables. Okay, sometimes a function of several variables cannot neatly be written with one variables isolated. For example, consider we have function. Okay, consider we have function. For example, x square y cube z plus cos y cos z equal to x square cos x sin y. This function, it would be practically impossible to isolate z alone any other variable. Okay, which means this is impossible to leave z equal to in term of blah 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 blah. Okay, in term of y x. Okay, for example, okay, this is impossible to leave it z as a subject. Okay, basically. Fortunately, the concept of implicit differentiation for derivative of single variable functions can be passed down to partial differentiation of function of several variables. So we will discuss about how to solve and how to use implicit function in order to solve partial derivative problems. Okay, so the outline today of this topic, the first one, we go to the introduction of implicit function, the theorem that we're gonna use, and also self-assessment. Okay, for the introduction to implicit function, okay, in implicit differentiation, differentiating functions of x with respect to x is straightforward. But when differentiating a function of y with respect to x, the chain rule method is applied as follows. Okay, for the implicit differentiation that we're going to discuss only in partial differential equation. For the ordinary differential equation, actually has been discussed or have been taught in diploma level or foundation level, or you can go back to the topic 1. Okay, calculus in one variable. Okay, for the theorem, actually, let's say if the function f, capital F here, notation for the implicit differentiation. Okay, if the equation fx y equal to 0 defines y implicitly as a differentiable function of x, then dy dx is equal to negative partial derivative of x divided by partial derivative of y, provided partial derivative of y is not equal to 0. So capital Fx here is implicitly differentiate with respect to x, and capital Fy here is partial derivative with respect to y. The capital letter we use here is basically the notation of implicit differentiation. Okay, so hopefully you can remember this formula to solve partial derivative for the implicit function. Okay, for example, we have y as a differentiable function of x such that x cubed plus 4x squared y minus 3xy plus y squared equal to 0. Then we need to find dy dx. So this function, we need to apply the theorem, which is dy dx equal to negative partial derivative with respect to x divided by partial derivative with respect to y. So firstly, we need to find the partial derivative of respect to x. This function actually, function f, as we assume that this function f is equal to 0. Okay. Partial derivative respect to x, or we can write into this form. So we get 3x squared plus 8x y minus 3x, and the partial derivative respect to y, or we can write into this form. So we get 4x squared minus 3x sorry, this one not 3x, negative 3y, sorry. Okay, and plus 2y. Okay, and then we substitute this result into this formula. Okay, therefore dy dx is equal to negative 3x squared plus 8xy minus 3y over 4x squared minus 3x plus 2y. That's it. Okay, let's say from this question, let's say we need to find the value of the dy dx. We want to find the value of this gradient given that point, for example, we have 1 and 2. Okay. Okay, sorry, I need to choose in color, blue color. Okay. Okay, for example, from the previous question, okay, x cubed plus 4x squared y minus 3xy plus y squared equal to 0. Okay, is it true? Okay. Then From this we want to find the point. Okay, what is the gradient which is dy dx if given a point of 1, 2. Okay, so from that result, okay, which is this result, dy dx that we get from previous 3x squared plus 8xy minus 3y over 4x squared minus 3x plus 2y. So at point 1 and 2 we substitute. Okay, we substitute into the value, the result of dy dx. Okay, 3 1 square plus 8 1 2 minus 3 2 over 4 1 square plus minus 3 1 plus 2 2 negative 3 1 square plus 8 1 2 minus 3 2. So we get 13 over 4 1 square minus 3 1 plus 2 2 5. Therefore, the gradient is negative 13 over 5. Okay? So hopefully you can do the self-assessment 5, and again you may submit letters by 22nd of November 2019. Okay, hopefully you understand what have been taught. Okay, thank you.